Okay, we're still making some minor errors, but it looks pretty good. You know, what we got to put here is something that when we multiply by x, gets rid of that 4x squared, right? So what would we multiply by x to get 4x squared? Obviously 4x. Now that's the same as saying, if we divide x into 4x squared, what do we get, right? It might actually be better. Didn't actually occur to me until just now to think. It was kind of occurring before, but not really. What do we put here? So we multiply by x, we get rid of the square term, okay? So it's going to be 4x so that we get 4x squared. Now, that's going to get rid of the x squared. And you understand the process well enough at this point to know that's a good thing. Okay, that's our first step. And then, of course, 4x has to also multiply the 2, which would give us plus 8x. And I think everybody got that. Okay? And I'm pretty sure everybody was on track for the next step. I think most people got it. I don't remember anybody wrote down anything wrong there. So, you know, we remind ourselves now that our goal was to get rid of that 4x squared, right? That's why we put 4x here. And then, of course, the 8x went along with it. Okay? So, what do we have to do mathematically to get rid of that 4x squared? Well, we've got to subtract it. Meaning, if we're going to subtract this, we better subtract this too. Okay, so we've got to subtract all these. That's why we put a little minus there with the parentheses, and this is where we put it. So that's going to be a negative 8x. Added to the negative 9x gives us negative 17x, which I think most people have. Okay? Then we have a plus 3. Okay? And now what do? Well, we're going to have to put something else here that when we multiply by this, wipes out that 17x, right? Negative 17x. So what do we got to put here?
Negative 17.
Yeah. If we put negative 17 here, then multiplying this by this, and we know that this is going to have to be multiplied by this to give us this, don't we? From what we just did over here in the check, that's our goal. Find out what expression we have to multiply by this to get this. That's what it means to divide this into this. Okay? So anyhow, we have negative 17, so that's going to give us a negative 17x. And negative 17 times 2, of course, would give us a negative 34. I think I saw somebody with a positive 34 there. So, and that didn't really quite look right because I was pretty sure the negative 34 was right. So if you had the positive 34, you just, watch your signs, that's all. Okay, just be careful about every step. Okay, so 3, and of course now, to get rid of that negative 17x, we've got to be subtracting this from this. And the 17x will go away. And we've got to subtract negative 34 from 3, which gives us plus 37. Okay? Now if you had a plus 34 here, you don't want a plus 34 there. Okay? Because that means when you subtract this, you'd have to subtract 34 from 3, giving you negative 31. Okay? So you want to be careful about that. Anyhow, so that's what we have. So (4x squared minus 9x plus 3 over x plus 2 should be equal to 4x minus 17 plus 37 over x plus 2. And then you want to check that. Okay? Now one way to check it is multiply both sides by x plus 2. I'm going to go ahead and check this one. Just using an alternative way of doing it, which is put this side over a common denominator x plus 2. And then the numerator better match this numerator, right? So, and this kind of reviews the whole thing of the common denominator. we're not trying to solve the equation. We're just trying to verify that the two sides are the same. If we were trying to solve the equation, we would not use the common denominator. We'd multiply through by the denominator, and we'd get an equation. Turns out just to be a quadratic equation that we can easily solve. Okay? So anyhow, we have this. So we write the 4x minus 17 is 4x minus 17 over 1. And we need a denominator of x plus 2. So we multiply the denominator by x plus 2, but we can't stop there because that would change the value. If we also multiply the numerator by x plus 2, then we really haven't changed anything. We've just changed the way it looks. Because x plus 2 over x plus 2 is just 1, and 1 times this is just 4x minus 17. We haven't changed. We just changed the way it looks. Okay, so we have 4x squared minus 9x plus 3 over x plus 2 equals multiplying this out, 4x minus 17 times x plus 2 over 1 times x plus 2. Just going to give us this, right? So now we get equals what? Okay, well, we multiply this out, we're going to get a 4x squared. And we're going to get an 8x and a negative 17x from the distributive law, giving us a negative 9x. And then it's going to be 17 times 2 is 34, but we've got a negative, so it's going to be minus 34 over x plus 2, plus 37 over x plus 2. And now we can add our numerators. Well, see, this equals 4x squared minus 9x minus 34 plus 37 over x plus 2. Since we have the same denominator, we add our numerators. And that equals 4x squared minus 9x minus 34, plus 3 over x plus 2. It's x plus 2, I don't know where that became 3. I think I was already doing that calculation. Anyhow, we see that this is the same as this, right? And now it's good. Okay? Now, if you really want to understand why you do what you do here, just do this until it becomes clear why. But you don't necessarily have to understand why, but you do have to, number one, know the process. Number two, check your results. Okay? Because if you just write it down the way you think it ought to be and don't check your results and verify that they're equal, you won't know whether you did it right or not. Of course, that means you got to do everything right over here, but you need to be able to do that much algebra, okay? So if you got to get a little slicker with your algebra, well, it's good practice, okay? So that's the process I want you to go through when you do a long division. And I've got, a full handful, but not quite 2 handfuls of long divisions for you to do.